Yeah, so welcome back to week number 2 for the Geo-Python course. And I guess I introduced myself briefly on Zoom last week, but I'm Dave and I'm the other course instructor and happy to be here in person. Of course, as I mentioned, being in southern France on the Mediterranean wasn't the worst thing in the world, but it's of course nice to be here and be able to see you, especially for teaching some of the lessons. It's really like the worst experience to teach on things like Zoom and not be able to see people's faces to know whether you're paying attention or know whether you're kind of following along, understanding things or whatever. But yeah, I think last week, from what I heard, everything went fairly smoothly. I know there's a couple issues that we'll get to. I know some people have been having issues registering for the course, and some of you who have registered late maybe have not gotten some important course information like this Discord link that's needed to complete today's exercise, or the exercise that's due today. So I think we'll extend the deadline by a couple days just for those of you who don't have the Discord link yet so that you can finish the first exercise. But we will deal with that when we get to the break. We'll put up a QR code so you can quickly join the Discord if you haven't done so already. And I think that'll be hopefully solving most of the issues. We'll deal with a couple other things in today's lesson that are kind of administrative things, but otherwise we're going to try to focus on some Python stuff and also things about version control. This has got kind of an annoying ring to the microphone. Okay, well, anyway, what did we learn last week? It looks like here, according to the poll responses, we got some basic Python and how to use Jupyter notebooks. That's good. Basics of how to submit stuff. Yeah, we're going to learn a different way to do the submission of your exercises today. And it's more in line with this idea of version control, which we'll come to. Learned how to do things in the course environment, how to use F strings. So I guess somebody must have read ahead because I don't think we covered F strings, unless Kamyar kind of, no. So that's good. We're going to come into using F strings again today as well. I don't know why I'm getting this feedback, but otherwise, some GitHub stuff, printing and combining variables, how to use the CSS note-based system. That's good. How to make a repo on GitHub. Basically, the lesson materials, it sounds like, more or less. So that's good. We will get more familiar with all of these things, the course environment, Python programming, using GitHub, and all of that in today's lesson and going forward in the course, as you might reasonably expect. While we're here, I think I'll just quickly switch our question. If you're still on the polling page, I'll maybe hide this one for now. And are there any kind of issues or things you want to maybe make us aware of now? You can, of course, just raise your hand and say something if you prefer. But if you want to sort of note any questions, problems, or other things, you're welcome to still do so while we're getting started. Again, at least we're aware of the things about some people not having access to Discord yet. And if you're having registration issues for the course, maybe during the break, it would be good just to come down and tell us, and then we can probably just add you kind of on the spot. So I know the late registration thing got a few people, and it's every year that it's like out of sync between the two courses or whatever. So at the moment, I guess I'm not seeing any questions, problems, or thoughts here, but I'll leave this open for now. If you have anything that comes to mind while we're getting started, you can, of course, add your feedback and thoughts here, just using the address that's on the board. And yeah, apologize if it's a little difficult to read, but hopefully you can tell what it says. All right, then. Let's have a quick look at where we're going for today in lesson number 2, week number 2 of the course. So essentially, we're going to continue getting our feet wet with learning things in Python. So we're going to take basically a continuation from where we left off last time and continue with some more I guess I would say kind of basic elements of Python. Most importantly, how to get groups of things into a single variable called a Python list. So we'll spend some time working with Python lists, and then going back to looking at some of the things we looked at last week, like different data types and those kind of things. The other big part of today's lesson will be about this idea of version control, which will introduce both how to use it and why it's useful to learn. We'll see where we are, whether we're at the break or before that we get started. But then you'll learn how to use this Git system that's linked to GitHub, and then we'll have our kind of good coding practice for this week about how to describe your code, which is basically just introducing how to put comments into the code to help you as a programmer understand what you've done in a language that you understand. So our lesson is on this basic elements of Python, and I think probably need to show you how to get the updated notebooks. So I'm going to go here to Noppe and log in. If you haven't done this already, you should go ahead and start up your CSC Noppe environment, Geo-Python 2024. So I'm just going to start my Noppe Jupyter Notebook instance. And then I can show you how to get the updated notebooks, because we'll need to do this for today's lesson. So here comes JupyterLab. This should hopefully look somewhat familiar. And I'll make it a bit bigger. Yeah.
Do we have any code so I can join the workspace as well?
Yes. So if you haven't joined the workspace, back in lesson 1 in the course environment section, you can find the section here about the cloud computing environments. It has the number 2 at the top of that page. If you click on that and just scroll down to the thing about the CSC Noppe, you'll see the course code is in the little note under here. It's some kind of character string, so it's better to maybe just copy paste it than. But yeah, if you haven't joined already, you can use the join code right here. But for those of you who have joined, we will need to go and get updated notebooks. I haven't actually gotten the notebooks yet. So I'm going to first maybe show again how to clone them, because I don't have them right now. And then I can also show you how to pull the changes or to get the updated notebooks. So at least if you're just joining for the first time, you can also follow along for this part. And for this, the most important thing is to go into the My Work folder. You guys did this last week, so probably many of you don't need to do this right now, but the My Work folder is where you should have this notebooks folder that you copied last week, and this is where anything that is in this folder will be preserved. Otherwise, things that are in the directories here will not, and that's not good. So I'm going to go here to the Git plugin and do clone a repository. Again, this is kind of a review from last week. But back in the course environment, there was the join code stuff, and then after that was this thing about once you join, you've got to clone this repository with our notebooks in it. And so I'm going to copy this address from there, paste it in here, and then click the clone button. So as a reminder, this is basically just copying these notebooks from a repository on GitHub. We'll get into the terminology about GitHub stuff, so don't worry if that sounds unfamiliar. But at least for me, what I see now is I have L1 and L2. Probably for most of you, you see that you have L1 and that's it. So how do you get the updated notebooks? Well, it turns out if you're in this notebooks directory, so if you're in the Noppe system, you go into My Work and then double click to go into notebooks. If you go back to the Git plugin, there's a couple of little cloud icons up here at the top, one with an arrow pointing down and one with an arrow pointing up. We'll deal with the arrow pointing up sometime soon, but for now you need the one with the arrow pointing down, which is on the left here, called Pull Latest Changes. If you click that, it should download a copy of the updated notebooks, and you should see this L2 folder appear. So for me, I click it, it says successfully pulled. It's actually not doing anything because I already have the latest files that are there. But for you, once you click that, if you go back to the file browser, you should see the L2 directory is now there. Is everybody able to get this L2 directory? Or maybe I'll ask this another way, like, can you raise your hand if you're having a problem getting the L2 directory? Because you'll need that for today's lesson, so. Looks like we're in good shape. So this process of getting, yeah.
Failed to clone.
Failed to clone. Yeah, okay, maybe Kamyar can give you a hand. But yeah, for the rest of you, hopefully you now have the L2 directory, and the place to go is into that directory, and then we're going to open up this Python Basic Elements notebook. And that's where we're going to get started. I'll make this one click bigger, and I'm just going to hide the file browser just so that we can see this. Yeah, question?
Can you show the link you copied?
Yeah.
Where is it?
Yeah, it's in the course environment under the section for Noppe. If you look just down below the instructions about how to join the workspace, it's the link that's here in the second note. Yeah. Yeah.
Just a general question, when I clone the environment in the my work folder, then it also automatically saves the stuff I type into the notebook.
That's right.
I pull it down, it still contains all the stuff I wrote in there, right?
Yeah, so the only place where you can get into trouble is if we were to update the things on the notebook, like repository where it's pulling the files from.
Yeah.
If we updated like last week's notebook, and then it pulled it, it would see there's changes on the remote thing and there's changes locally, and then you get this kind of what's called a merge that has to happen where it blends together these two things. Sometimes it can do it automatically, like if we change something in one section of the notebook and you change something somewhere else, Git is smart enough to say, okay, well, we can just put these two together. If you change stuff in the same spot, you get a merge conflict, and that's something that we'll mention, but it's we don't really go into it in detail because it's a little bit tricky to fix. But essentially, the stuff that you did last week, our plan is we won't update the previous week's notebooks. So anything you do, like during the lessons, each week when you pull down the new notebooks, you only get the new stuff, and your old stuff is preserved. Yeah, it won't blow anything away, so that's good. Okay, so on to our lesson for this week. And as I mentioned, Python lists are what we're going to be talking about. And a list in Python is a collection of different values that are all connected into and stored typically with a single variable name. So there's several different kinds of collections in Python. There's lists, there's tuples, there's other kinds of things. But it's basically a way of grouping together multiple values into a single name so that you can work with things like collections of related values. So for us to get started, we have this list here that's already in the cell that you have in the notebook. That's a list of different observation stations from the Finnish Meteorological Institute. And so we have the station names here. And what you can see is we have this square bracket that indicates we're putting values into a list. And I'm just going to fix the formatting here for a second just to make this easier to read. This is kind of automatically formatted for the web page, so it doesn't take up too much space. But normally, a Python list looks like this. So you have these square brackets that indicate you've got values inside of a list, and then you have values here, in this case, some text strings for the names of different observation stations, and they're separated by commas. So when you run this cell, you don't necessarily need to format it like I did. You can leave it how it is, but when you run it, it's going to store the values into a variable called station names. And if we just print that variable out by typing in station names, and then I'm just going to press Shift Enter, or you can press the play button to run the cell. You can see here now our 4 values, again, separated by commas, very similar to the format that we actually put things in when we typed it in earlier. So we have these 4 values in our list, and if we check the data type like we did last week with this type function, so you can do type and then type in station names, like that. When we run the cell, we see a data type we haven't seen before, and that is here our list data type. So last week I think you guys probably saw the int data type for whole numbers, integers, float for these decimal values, and I guess str, which is the character string, or for text typically. I think those are the only 3 you would have seen last week. Maybe Boolean values were mentioned, but I don't think we did anything with those. So we'll come to dealing with those later. But yeah, we have this new data type called a list, and this is a very handy way to be able to work with groups of values, because it turns out lists are very flexible and allow you to potentially have hundreds or thousands of values in a single variable that you can then easily work with. So how do we do things when we want to interact with our list? One of the first things you might want to know is, how do I get to and reference a single value out of a list? Because if you just type in station names like this, you get all the values of your list. And if you wanted to, for instance, get the first value out of the list, you would put in the station names variable, and then you put a square bracket, and you might think here, what we can put into our square bracket is a number that references a location in our list. And so if I run this with the number 1 inside the square bracket, I get Helsinki Kaisaniemi, which you might recognize is actually the second value in our list. So that might sound a little bit odd that you put in the number 1 here and you get the second value. But this turns out this is a very common thing in programming languages, that the listing of values, or the sort of numbering of values in collections, starts from the number 0, not from the number 1. So in order for us to get the first value out of our list of station names, we have to put the square bracket and then 0 in there to get our Helsinki Hanmaja value. This will maybe take a little bit of getting used to, but it's common in many different programming languages. I think C and C++ do this, Java does this, Python, I'm pretty sure R does something like this. I don't know about MATLAB. MATLAB might start indexing at 1. I don't know if anybody uses MATLAB, but Fortran does, but no one uses that anymore. So this is just something that'll take a little bit of getting used to. The indexing starting at 0, but this number, what's in here as our number 1 or our number 0, is what's called an index value, and that is our way in which we can reference values from within a list. If there's 4 of them here, we can pretty easily see which is number 3 in our list. But if you have thousands of values, you may want to be able to refer to value 500 and not scroll through counting them. So the index value can be quite handy for things like that. So now we have a little analogy for how index values and Python lists work together, because typically when getting used to this idea of how to reference a value out of a list, it's nice to have something that's maybe a little bit more familiar. Probably in your, let's make this smaller. Why is that getting bigger? All right, trying to zoom out. There we go. Probably in your experience, sometime in your life, you've been desperate for food somewhere and you've used a vending machine. It might not have been such a fancy vending machine with tacos and hamburgers and stuff like that, but the vending machine idea is actually quite similar to how you reference values inside a Python list. And that is essentially you have an item in the vending machine, whether it's a hamburger, cookie, or lollipop. And then when you put your money into the vending machine, it asks you, okay, well, which item do you want? And you have to push one of the numbers or combination of numbers and letters to get it to give you the item that's in the vending machine. So for instance here, if you wanted this nice vending machine cheeseburger, you would press number 0 on the vending machine, and then it would give you your desired food from the vending machine. So this is very much like how a Python list works. We have our items in the list. In this case, our first list we started with had these 4 different FMI stations, and then we have a way to reference those values, which is our index. So if we took this analogy, and I really hate this ringing sound, so I'm sorry. Maybe I'll try the other microphone after the break. What we can see if we look at this is we could basically treat our vending machine bill just like a Python list by saying, okay, let's print out the value in our list called bill, which is our vending machine, at index number 3. And it says taco. And if we look back up here, yes, sure enough, the item is the taco, and the way that we reference that item is with our index value, in this case, number 3. So when we get into this week's lesson, when you start interacting with Python lists, there will be cases where you'll need to use the index value to refer to something in your list. And you can think, okay, it's just like a vending machine, and hopefully that helps to make the connection between how these things work. Because it is a little bit confusing when you're getting started with these kind of collections and how to reference values from them. So in essence now we have some idea of how to make a list in Python. We can play around more with this during this week's exercise, so you'll get some hands-on experience creating the list. We didn't feel like it's that worthwhile to make you type in all these FMI stations to actually type in the list yourself, but they're relatively easy to construct. But another thing it's typical to want to know for your list is how many values do you have in the list. And to do this, we can use a function called len, which is short for length. And then we can put in the name of some list like station names in there. And again, for functions, we use the regular parentheses. So this will be something that will be maybe a little bit confusing also at the beginning. It's like, how do I know which one of these kind of bracket things to use? For functions, it's always parentheses. For lists, it's going to be square brackets. And we will use dictionaries at some point, and they use the other curly brackets, but we'll save that for later. So when I type in len and then the name of our list, I can see there's 4 items in the list. And if you remember, we had 4 items in our the number of stations that we had. So all of this looks good so far. So what about doing things like, what if you want to get the last value out of the list? And when you have 4 values, again, okay, this is kind of a trivial example. It's sort of silly to give you 100 different FMI station names in a long list and make it kind of clumsy to look at on the web page, so we keep it short. But often you want to say, okay, like what's the last value in my list? And you might think, okay, well, let's go station names. And I just figured out how many items I have in my list. And there's 4. And then you run this and you get an index error. Now that might seem a little bit confusing. However, remember that the indexing starts at 0 in Python lists. So when we want to get the last value, it's not number 4, it's 0, 1, 2, 3 as the way that we get the last value out of a list. And again, this makes more sense to do it when you have lots and lots of values, but you don't have to know how long the list is to access the last value, it turns out. There's a nice trick in Python for getting that. But here, just for a second, this index error, because you're going to encounter these errors, you're going to get these pink little code blocks that pop up in your code when you're learning to program. That's part of the process. The index error here is indicating there is a problem with us trying to reference a value from this list. And it even tells us that the list index is out of range, which might sound a little bit like a weird phrasing. A lot of programming things sound a little weird at first, but all it's telling us is that we're trying to refer to a value from a list that's not in the list. So if we try to put an index value that is, bigger than the total number of items we have in our list, we're going to get this index error. And it's a good thing whenever you get these kind of pink code blocks popping up to just take a look, pause for a second, and I know it's kind of an alarming color that maybe triggers you to think there's something wrong, and I don't know, gets like an emotional response of what have I done. But if you take a breath and look at what it says, a lot of times these error messages, they're there to help you figure out what's wrong. And so it's good to just pause and read it. And then if you don't understand what it means, copy paste it into Google or DuckDuckGo or whatever web browser search thing you want to use, put it in there and then try and find somebody who explains it in a way that makes sense, because these error messages are exactly there to help you fix problems. In this case, we've referenced a value that's outside of the range of our list. So if we want to get the last value, as I mentioned, we could either change this to the number 3 because we know there's 4 values there, and 0, 1, 2, 3 would give us the Helsinki Kumpula station, or we can use this clever trick in Python, which is to say, let's go to index -1. So this is a super handy thing. If you want to get the last value out of a Python list, you can actually put in negative index values, and they will start from the bottom of the list and go up. So again, it's a common thing to get the last value out of a list. You don't need to know how many items are there. You just put in the index -1 and it gives you the last value. And in fact, you can go up and even go further up the list and say like station names and go to index -3 or -4. -4 would give us our first value in the list because we'd go from the bottom of -1, -2, -3, -4 is the first one. But just like we saw before, we can also break this by going to index -5 or higher, lower, whatever you want to think of, where we get an index error again, because of course you can also go outside of the index range going backwards from the bottom. You can get to basically a value that doesn't exist at the start of the list. So same kind of error message here, list index out of range, which just means that we can't go to find a value at index -5 because there's only 4 values in our list. All right, so then, well, we just saw what happens. I think I'm kind of one cell off in the lesson right now with what we're doing. But this brings us here to a question. So we have our list of cute animals here. I think I've made this list probably several years ago now, but I think these are all considered still cute animals. So we have bunny, chick, duckling, kitten, and puppy as our list of cute animals. And if we go here to our poll, let's hide this one and make this one visible. You have the question before you. If we are to look at our list of cute animals, which animal is indexed or at index -2? And then you can choose one of the 5 options here from our list of 5 values. So take a second and you can go to the poll page, or if you hopefully kept that tab open, you can go there and vote, and we'll continue in just a moment. Okay, so at least based on the poll results, there seems to be a clear leader so far at this point. So we have our list of cute animals, which is at index #2 on our list. So as a reminder, when we go to using negative index values in a Python list, we're going to start at the end and go backwards. And so index -1 would be puppy, and index -2 in that case would be kitten, which of course, because anything internet, kitten is the winner. We end up here with kitten as what we would expect at index -2. If we did index +2, we would start at 0, 1, and then end up with duckling as the cute animal that's chosen, but in this case, when we do negative indices, we go backwards. And if you just want to verify this, we could copy paste this list of cute animals here. And we could put in then cute animals and then index -2. And if you run that, you should see that you do indeed get kitten as the expected cute animal here. So that's a little bit about how to make a Python list and how to use index values. And now we can move on to our next topic about modifying list values. So one of the nice things about a Python list is that it is what's called a mutable data type. Funny word, but it means just that it's a data type that can be modified. So when you create a Python list, you can modify the values in that list. And there are other data types where you can't modify the values, for instance, with tuples. But these are changeable things. So if we have, for instance here, instead of the names of these FMI observation stations, the type of station that goes along, we had our 4 stations before, and we can make this list called station types, which again starts with a square bracket and ends with a square bracket, and it has these comma separated values in it. And it says weather stations, weather stations, weather stations, weather stations. Kind of boring list, to be honest. We could populate this in a different way if we wanted to, but this is, we're just making our list right now. Now, let's envision that the third station is actually a mistake in here. It's not supposed to be a weather station, but instead it should be a Mario graph, which is what's here. So we can change that. And the way that we change it would be to say, let's go to station names and our index #2, so our third value in here, let's change that to, instead of being weather station, yeah. Sorry, station types. Thank you. So station types #2, or index #2, and then we'll put in Mario graphs. So you can see it's in single quotation marks here, and I put it in double quotation marks. It doesn't actually make a difference in Python whether you use single or double quotation marks functionally. Double quotation marks seem to be preferred in some style guides in Python, but it doesn't matter if you do single or double quotes, just as an aside. But if we change that and then we just print out our station types, run it like this, we'll get our updated list printed out, and so now you can see we have weather stations, Mario graphs, and weather stations. So we have indeed updated our list of station types compared to what we had previously, which is what we want. So that's a nice thing. If you want to change a value in a Python list, you just use the index to refer to which value you want to change and assign a new value to that value. And we'll talk about, or to that location. We'll talk about how to delete and add values to the list in just a few minutes. But another thing we can do here is we can make another list, and luckily for you, you don't have to type anything in here. We just have to run these cells. But we're going to put in some information for the Helsinki Kaivopuisto station. So we're going to make a list that instead of having station names or station types, we're going to have one station with several different pieces of information about that station. So it has a station name here, Helsinki Kaivopuisto. It has a station ID, which is some FMI internal number thing they use for referring to their stations. It has a latitude and longitude with not much precision. And then it has a station type, which is Mario graphs, which is like what we had before. Just going to run those 5 cells. So we're going to assign values to these different variables: station name, station ID, station lat, station lon, and station type. Then here, we're going to make a new list, station Hel Kaivo, which is just a sort of name we're going to give to refer to this. And in there, instead of having text strings, because you don't have to have a text string in here, we're going to put in our different variables. So we'll have our station name, station ID, station lat, lon, and type. And then if we print out that list, we'll see what we have in there just by running the cell. So you can see we have our Helsinki Kaivopuisto as the first value. It's in quotation marks, indicating it's a character string. Then we have a number, Then we have two other numbers for the latitude and longitude, and then Mariagraphs, again, is a character string. So what we have now is different data types in our Python list. And this is actually one of the nice things about a Python list is it doesn't have to be all numbers or all character strings. You can put basically any kind of data into a Python list. Even other Python lists can be inside lists, which can get a little confusing when you're trying to reference values, but it's possible to do that. So we've made this now. If we check our station hel kaivo data type using the type function, so station hel kaivo, can't see my keyboard. Of course, we see that that's a Python list, so it returns back the data type list. Then if I just copy this contents of this cell, and I'm just going to paste it here because it's easier than typing this in another time, we can add the square brackets after this and get the value in the first location of our list. So if we go here to the first item in our hel kaivo list and check its data type, when you run this, you now see that you get back type str, which is sort of expected. Our station name was a character string, and we're referring to that variable now inside of our list. Okay, it doesn't know that it's station name in the list. It just knows that it's this character string, and so it returns str as the data type. And if you copy that cell, and you can paste it in here, we check value number 1 at index 1 and value at index number 2. So that's our station ID, which this is a whole number, so it should give us an integer data type, and this is a floating point number, so it should give us a float data type. If you run those cells for those two cases, you can see now we get data type int and data type float. So that's just proof that we can put different kinds of data types into our single Python list. Yeah, there are benefits to this. Like when you want to group values together, in examples like this, where you want to have, for instance, latitude, longitude, and then some text that describes the location you're referring to, Python list can be kind of a handy way to do that. There are some drawbacks to it because it can be, when you get really big lists, a little bit slow to access and interact with the values there because it's flexible, and you don't necessarily know what kind of data type you get at each point inside your list until you check it. It can be a little bit slow to access data for really big lists. There are some more efficient data types to use when you have those cases, but for our purposes, it works perfectly fine. Until we get into like the later weeks in the course where we might have something like tens of thousands of values stored in a data collection, it doesn't matter that we're using lists for right now. All right. Let's continue with a few things here about how to add and remove values from our Python list, because this is also something you might want to do, whether you added a value by mistake or you just want to prune away some of the values that you don't want to work with. It's a common thing to do. Let's just remind ourselves first off our station names list. You just type in station names and run the cell. You can see again our 4 stations that we've been dealing with since the start of this part of the lesson. If we wanted to remove one of them, we can use a statement called del, which is short for delete, and then we could say station names, and importantly, give the index value. If you just type del and then station names, you'll delete your Python list. So you want to give the index value here, because all we want to do is delete the first value, not the whole list. So we run that. It's going to remove the value at index 0, so our Helsinki Hanmaja should go away. And then if we check station names, station names. Now, just by running that, station names is not, I got to spell it right. You can see now we have only 3 stations for Kaisaniemi, Kaivo, Puisto, and Kumpula because we deleted the first one. There are other ways to do this. It turns out deleting values from Python lists is not that common of a thing to do, but if you're interested, there are some other ways to both use this remove method to remove a value with, if we put in Helsinki Kaisaniemi in quotation marks here, it would remove the value that's named as Helsinki Kaisaniemi, or there's pop where you can put in the index value. It works similarly, but del seems to be the kind of most common to remove a value. But as I mentioned, removing values from lists is kind of just generally not something that you do that often. It's much more common to be adding values to lists, like if you're going through and running some code that's kind of reading some files and you're adding things as you go. That's a more typical case. And for that, we can use something here that is a method called .append. So we could say, for instance, station names .append. And if you want to just type this in a short way, you don't have to type in exactly what I'm putting for the character strings here, if you just don't want to feel like typing that much. But we could do Helsinki Lighthouse. And we can do station names .append. And what do we have? Helsinki Malmi Airfield. So I think that one is still operational, even though the Malmi Airport is no longer kind of operating. I think that observation station still works. It doesn't matter for our purposes. Just when we run this, we're going to append two things to our list. So if we check now our station names, we can see now we have 5. So what we've done mathematically is we had 4, we took away 1, then we added 2 more, and now we have 5 stations in our list of station names. So I don't know if you guys saw these kind of methods last week. I guess maybe not. But .append is a specific kind of function that can be applied to a Python list. So it's actually built into the data type Python list that you can append things to them. So you'll note that we didn't do append and then give the name of the station as a regular kind of function call, but instead we gave the station names and then .append. So this is a function, but this append function is something that works because we're dealing with a Python list. So if we wanted to, for instance, try to make a new variable here with our station name length. So this is the length of the number of stations we have, for instance. And we could use our len function to get that, and then station names. If we wanted to assign this value, that's perfectly fine. We can do that, and we know that from using the length function before, we should get a number 5 that's assigned to station name length. And if we check its value, station name length, if I can spell it, indeed there's 5 is the number that gets stored there, because the len function just tells us how many values are in this Python list. Okay. If we check its data type with the type function, station name length, you already know what to expect here, right? It's an integer value, and sure enough, the data type comes back as int. If we try to append something to an int, like if we did station name length .append, and then let's say the number 1, we don't know how Python works, we're going to try to add a number 1 to our 5 by using .append. What you get here is an attribute error, which is essentially just telling us that there is no function called append for a data type integer. So this is the point I guess I was trying to make a moment ago, that .append is something that's specific to Python lists. Because it's a common thing, you've got a group of values, you want to add one. Appending is the way that you can add things to a list, and so .append works. When you have a number, there's not really something logical that's going to happen when you append to a number. Like, it's not a list of values, it's a single thing. So it tells us here that like there is no function or there's no attribute called append for the data type int, because that data type doesn't have this built-in function. A Python list does. And we'll see more of these as we go on through the course. Yeah?
If I try to append a specific value to an index which already has a value, will it override it, or will it?
So like if you were to take, well, let's try it out here. So we have our station names, right? And we did station names.append earlier to add something to it. But you're saying like, what if you went to like station names 0.append?
Yeah. And then give it like a station name.
Again, you're going to get the attribute error here, because what you're actually referencing by using this station names and then the index 0 is the string of text. They are not the Python list. And so similarly, it says, okay, well, string also doesn't have an append. So then you get the same basic error, except for it tells you that the string data type has no append. So yeah, I mean, you'll see like some of these things will be a little bit confusing because the functions that you're going to use are specific to a data type, and you might think, oh, I'm using a Python list, and actually realize that, oh, actually I was using a number or something else. But when it makes sense, a lot of these functions are built into the data types, because like adding things to a list is a super common thing to do in Python, and it makes sense to have a built-in function to the list data type to be able to do that. Okay, where are we at here? I think we are, let's get through a couple other things, and then it's going to be break time, because I think this sort of mental energy is going to start fading here pretty soon. But I'll show you a couple other useful list methods, and then we'll have a break and continue after that. So there's this list method called .count. So station names .count. What will that do? Well, it expects you to give, actually could be kind of any value that you give here, but if we say, for instance, Helsinki Kumpula, it's going to go through our list and count how many times Helsinki Kumpula occurs inside the list. So this can be a useful thing. For instance, if you had read data from a file and there could be missing values in there, you could do a count for how many times you have basically a no value inside your list to figure out how many missing data you have. Here, when we do station names.count, Helsinki Kumpula is only in our list one time, so we get back that it occurs once in our list. Similarly, we could do station names.index and also give Helsinki Kumpula here. This works similarly, that it's going to go looking for the character string Helsinki Kumpula in our list station names, but now instead of telling us how many times it occurs in the list, it's going to tell us the first time that it encounters that value in terms of the index. So what it returns here is the index value where this occurs in our list, but it only does it for the first occurrence. So it will only ever return one value, which would be the first time you encounter Helsinki Kumpula in the list. So if you, for instance, didn't know what the index value was, but you wanted to see whether a value was in the list or figure out how to access and modify it, you could use, for instance, the index to find the value, or .count just to simply see if that string of characters, for example, occurs anywhere in the Python list. Again, when you have 5 values, you can also just print the list and look at it, but when you have 5,000, things like these kind of methods become quite useful. Another one that's a common one to use is reversing lists. So for instance, if you've read things in that are related to time, if you want to sort of sort things instead of like, oftentimes it's going to be sorted either increasing forward in time or going backwards in time. And if you want to flip it, like geologists like to do sometimes, then the .reverse method can be quite useful for that. So if we take our station names and do .reverse, like this, we'll run that one and then take a look at what we have in our station names. I'll just print the values out. what you can see is that compared to what we had before, now everything is in reverse order. Probably not a big surprise that dot reverse does that to a Python list. However, there is one thing that might be a big and can sometimes be unfortunate surprise, is that you have to be careful with this method, because you'll notice that we did not say station names equals station names dot reverse. When you do this dot reverse, it updates the list in place. So that's kind of handy in a way that you don't have to say station names equals station names dot reverse, but it also is different than some other things work in terms of how you interact with different data types, because often when you want to update the values in your original data type, you would have something and then an equal sign and then what you want to update it to. Station names dot reverse does this in place, and I think I'll just, for the sake of demonstrating, I'll add a couple cells here just to show you. But we had our station types from before, right? It was this weather stations and then Mario graphs thing. If I did station types equals station types dot reverse, kind of a logical looking thing to do. Say like, I want to reverse the values and then update my station types. If I run this, it runs perfectly fine. But if I go back then, because of course you can do this in Jupyter Notebooks, you can go back to a previous cell and run again. Now I'm going to run this with my updated station types, and what you'll see is that, what's this look like? There's nothing here. And if I print it out, I get none. So it turns out that this function, when it runs, it returns a value of none. So if you assign it like station names equals, or station types rather, equals station types dot reverse, essentially what you do is you delete your list. So that's why there's this kind of bold text, do not do this thing here, because this is a very effective way to delete things, but it doesn't actually reverse, well, it actually does reverse the values and then deletes them. So it's both wastes the sort of computer processor time and then ultimately deletes the list that you're trying to update. So this is just a warning, because you'll see lots of other places where we're going to say, if we want to update our values and we say, let's assign this with an equal sign, this is a notable exception. And be warned. So I hope we don't need the station types later in the lesson, because I've just deleted it, but we can go back and fill it in again later if we need to. Dot sort is another useful one. So station names dot sort. Again, this works just like dot reverse, that it will delete the thing if you assign it. But then if we look at our station names after running dot sort, you can see now that they are in alphabetical order. So dot sort like this will sort things alphabetically. It will also sort number values numerically. So you can see here that we have Kaisaniemi, Kaivopuisto, Kumpula, Malmi Airfield, and Lighthouse. I think before our list had been updated to be Malmi Airfield, Lighthouse, Kumpula, Kaivopuisto, Kaisaniemi. So in essence, it's not quite reversed it, but it's sorted them alphabetically. You might be wondering about this, why L occurs after M in some process that supposedly sorts things alphabetically. And that has to do with the fact that when you store characters in the computer's memory, and in many programming languages, capital letters are sorted first, and then lowercase letters are sorted second. So if you have something like this, where you have Helsinki Malmi Airfield with a capital M, the M will occur as the sort of sorting of the capital letters, and then when it sorts the lowercase letters after that, then the L, lowercase l in Lighthouse would occur second. If you want to demonstrate this, we can do that, because why not ad-lib a little bit and make this a bit more interesting. So we could, for instance, say station names, and let's go to our index number 3, right? So 0, 1, 2, 3. And let's make our Malmi a lowercase m. You don't have to do this if you don't, I mean, you can just kind of watch this part if you want. But let's do that. Let's take a look at our station names list now. Okay, we've updated this Malmi to be a lowercase m. And if we sort again, and then look at our list, what you can see is that now it flips it, because lowercase l does indeed come before lowercase m when you do sorting alphabetically. But uppercase m comes before lowercase l, which maybe takes a little bit of getting used to, but this kind of explains why the stations were out of order when we sorted them the first time. It's easier with numbers because numbers are numbers, unless you get into dealing with like weird, like imaginary numbers and abstract things like that, then I don't know how Python does that sorting. But normally it sorts in a fairly intuitive way. So that's a useful thing to be able to do. And I think our last thing we'll do maybe before our break, because I think we'll take the break here with a couple questions that you can have a look at, is we'll talk about how to get different data types to work together. So we've been dealing with Python lists. We're going to continue in a sense with Python lists in other parts of like the exercise for this week. But for right now, let's talk a little bit about how to get different data types to play nicely together, because we have things like numbers and text strings that we might like to be able to combine in some different ways, like maybe printing them to the screen or things like that. But we had these variables we assigned earlier, our station name, ID, lat, lon, etc. And for instance, if we look at station name, actually let's take a look at its data type. Type of station name. It's a character string. No surprise. I think it was it Helsinki Kaivopuisto? I don't remember what we had assigned there. And then we have a station ID. And if we look at its data type, you might remember it was this 6-digit number. It's an integer. And then we have something like our station lat, which we can look at its data type. And it's a floating point number. I think that was our latitude. Name is kind of intuitive in that case. Some of these data types will play nicely together and others won't. So like if you imagine you add together two things that are numerical, Python says, okay, easy. Integer, floating point number, I can add those together, no problem. But if you try to add things like station name, BAME, name, plus station, let's go ID. When you run this, you're trying to combine station name, which is a character string, with the station ID, which is a number. And when you run that, you get a type error. The reason you get this type error is because it doesn't know how to combine a character string plus a number. It's like ambiguous what you're trying to do. Are you trying to make this a character string that includes that number? Are you trying to do something mathematical with this number and the character string? Python doesn't know what to do. You get this message here about the type error saying can only concatenate, which is kind of a fancy word for add together, string, not int to string. So it's possible to take text plus text, and Python will add that together just by merging the two blocks of text. That's fine. But it doesn't know how to take a number plus character string and do something with that. And it gives you this message here. In order to do that, we have to do what's called a type conversion, where we take our data type and change it from an integer or floating point number to a character string, for example. So we could take something like our station ID and make a character string version of it, which we'll just call station ID underscore str. And then we're going to use a function here called str, which is a function to convert something from some other data type to a character string. And then we can put in station ID here. So this is going to convert our number into a character string. So station ID str equals, this is the string function, and then here's our station ID, which is a integer number. We run that, okay, what did we get? We got station ID str. So we can first take a look at what the value is here, and here is our station ID that we had before. But now you can see it's wrapped in quotation marks, which indicates that it is a character string. And if we wanted to confirm that, we could type in our type, station ID str. And when you run that, sure enough, you get back that it is of type str, meaning it's been converted to a character string. By doing the type conversion, we've done a step in the direction of making it easier to put our data types together, because we can do sort of things like add character strings together to make a nice looking print statement. And for this part, we're going to leave you maybe with 10 minutes of break time and a couple questions that you can answer either before or when you come back, about what you would expect to see for these different scenarios. So the first question is what you would expect to see when you print station ID plus station ln. So you can kind of have a look. It's a multiple choice thing. We'll put the poll question up in just a second. And the second question is what you would expect to see when you print station name plus station ID str. So these are your questions to answer while we take a 10-minute break. So it's I've got 21 minutes after 10, or 22 minutes after 10. So let's come back in 10 minutes or so. I'll put the questions up and we'll continue after that. We'll also try to make visible on the screen the little QR code if you haven't joined the Discord yet, that you can join Discord. And finally, if you're having problems with registration, come see us during the break. That might be useful. But let's make these questions visible first. So there's question number 1 and question number 2. So you should see them both here on the polling page. And let's continue in 10 minutes.